All right, let's dive into something that is absolutely fascinating. Today, we're talking about a condition that really opens up this incredible window into how our brains work, and specifically, how we use language. We're going to demystify aphasia. You know that feeling, right? When a word is right there, it's on the tip of your tongue, but you just can't quite get it out? It's so frustrating. Well, imagine that feeling, but magnified 100 times over. Imagine the very connection to your words, your ability to speak, or even to understand what people are saying just vanishes. That is the reality for someone living with aphasia. So, what is it exactly? Well, aphasia is a disorder that messes with our ability to produce or understand spoken language. It's almost always the result of some kind of brain damage. We're talking from a stroke, a serious accident, or maybe a tumor. But here's what's so wild about it. By studying aphasia, researchers get these unbelievable clues about how our brains are actually wired for language in the first place. Okay, so to get our heads around this, scientists have kind of broken it down into two main types, two really well-established syndromes. You can think of them as two sides of the very same coin. They're called Broca's aphasia and Wernicke's aphasia. So first up, let's talk about Broca's aphasia. For patients with this, speaking is a real struggle. It's slow, it's halting, it takes a ton of effort. And their speech has this thing called agrammatism, which basically means grammar just goes out the window. All the little connecting words, the ands, the thes, tos, they get dropped. So instead of saying, I am going to the store, you might hear something like I, go, store. The words they do use are usually these very concrete nouns. But, and this is so important, they can usually understand what you're saying to them pretty well. Now let's flip to the other side of that coin, to Wernicke's aphasia. And this is a completely different picture. The speech here is actually fluent. It's fast. It sounds totally normal. It's even got complex sentences and all the right grammar. So what's the problem? The problem is that the words themselves are all wrong, leading to sentences that don't make any sense. And here's the biggest difference. Their ability to understand language is severely damaged. And what's really fascinating and kind of sad is that the patients often have no idea that what they're saying is nonsensical. Okay, so let's just put them side by side to make it super clear. With Broca's, you get non-fluent, effortful speech, but you can understand pretty well. With Wernicke's, you get fluent, rapid-fire speech, but comprehension is just gone. See what I mean? They're almost perfect opposites. It really shows how specific the damage to our language system can be. But of course, when we're talking about the brain, it is never that simple. It's just not. While having these two big categories is helpful, the reality for actual patients is way more complicated. And this leads us to this huge puzzle that scientists have been trying to solve for a long, long time. So here's the big question. If these two types are so clear-cut, why doesn't every single patient fit neatly into one box or the other? Why do the exact symptoms change so much from one person to the next? Well, that's led scientists down a few different paths. There are basically three main theories for why there's so much variation. First possibility, maybe everyone's brain is just a little unique, you know? Like our language centers aren't in the exact same spot for all of us. Second possibility, maybe a language is so specifically located that a difference of just a millimeter in brain damage can cause totally different symptoms. Or there's a third idea, and this one's a bit more recent, and it's called the neural crossroads theory. This theory is awesome. It suggests that Broca's and Wernicke's areas aren't just single spots for language, but they're more like massive, bustling intersections for linguistic information that spread all over the brain. So think of it like this. Damage to a major information superhighway is going to cause a way bigger, more chaotic traffic jam than damage to some quiet little side street. It just makes so much sense of why the symptoms can be so varied. And the complexity, believe it or not, doesn't even stop there. Beyond those two big pillars, aphasia is really a whole spectrum of conditions, with other types that show just how many different ways our language process can break down. So let's just run through a couple more. You've got jargon aphasia, where speech is fluent but it's just peppered with complete nonsense words. Then there's conduction aphasia. This one is so specific. A person can understand you, but they are physically unable to repeat back what you just said. Then there's transcortical aphasia, which is basically the opposite. Repeating words might be the only thing they can do well, but they don't actually understand what they're repeating. And finally, anomia. Remember that tip of the tongue feeling? Anomia is like that, but for almost every single word.
Okay, so after all of that, what's the big takeaway? I mean, what does looking at all these different ways language can fail tell us about our own minds when they're working right? Well, it reveals something truly profound about how our brain organizes the very idea of a word. And here it is. This is the absolute key. Aphasia shows us, without a doubt, that our brain treats a word's form, what it sounds like, its grammar, completely separately from its meaning. Just think back to Wernicke's aphasia. The very fact that someone can produce a perfectly grammatical sentence that is total gibberish is the ultimate proof that the structure of a word and the concept behind it are handled in two different places in the brain. And that leaves us with this final, kind of mind-bending question to chew on. If the sound of a word and the actual meaning of that word are stored in totally different parts of our neural hardware, then what even is a word? It's a puzzle that starts in a hospital, but it ends up making us question the very nature of how we think. Something to think about.
So, if you like videos like this, make sure you subscribe to our channel, hit the bell icon to get notified every time we post a new video, and share this video with your classmates, teachers, and friends. Thank you all for your input. Let's keep this process efficient and on track.